Can you talk the talk? Can you talk about ARP in the context of a real network with 3 different subnets and talk about what ARP table entries should exist and what messages should flow? That's what this is all about. Get ready for your technical interview. Let's go. For this technical interview, I'll use this diagram on the left. It shows the router interface IDs for reference, and it shows the IP address and mask for each relevant interface. So what do I ask of you? So you're being interviewed, I'm interviewing you, and I'm going to expect you to respond. And I want you to talk to me about the ARP tables in this design and the messages, the ARP messages that have to flow in the following case. To begin, let's assume all the ARP tables on all devices are empty. Now that's hard to create in real life because these devices all want to send traffic, right? But let's start assuming they're all empty and that when PCA generates a packet to send to server S2, then that's going to be the event that causes these devices to generate ARP messages and fill up their ARP caches, all right? So that's the driving event. So for that packet to go from host A to server S2, and then for server S2 to send a return packet back to host A, what has to happen in terms of what ARP is up to? That's what I want you to tell me during this technical interview. So I want you to describe all ARP table entries that will exist when this process is done. Who creates the ARP request messages and ARP reply messages to make that happen, and what info is sought by each of those ARP requests. So just talk me through as much of that as possible. I wouldn't expect you to get every last little detail correct, but that's what I would be listening for. Now for the MAC addresses are long and hard to work with. So for the sake of discussion, I would say use generic MAC addresses like MAC1 and MAC2. So I might write those up here, MAC1, 2, 3, 4, 5, 6. For instance, MAC3 used for this R1 gig 010 interface, right? So just use generic MAC addresses for the discussion. All right, so that's the scenario. For the style, like all these interview review questions, I want you to speak to yourself or to others, but try to speak it out loud somewhere, or you could write an answer if you like. So just type something in. You could even post the scenario and write your answer on a public forum if you want somebody to check your work. You can post what you're thinking about here at the YouTube channel. That's fine as well. Just give me some context of what you're trying to describe or which particular piece of it you're writing up if you do that. When you do it, I want you to try to be as accurate as you can. Use as much terminology as you can to, practice that, and be as clear as you can. Strive for clarity. So now's the time to hit pause and prepare and go and do the interview review on your own. Find somebody to listen to you talk about it, think about it, talk about it, write about it. And here's a few seconds to hit pause and go do that. So let's talk about those ARP tables, but first, one more chance to hit pause and go do this for yourself if you haven't already. If not, here we go. So on the left, we have a repeat of the topology and some of the facts. But now let's talk about ARP for a moment, generically speaking. ARP lets a device learn the MAC addresses used by other devices, but those devices aren't all devices. Those devices are those on the same LAN in the same subnet. And that's because ARP uses a mechanism where the ARP request is encapsulated inside an Ethernet frame, and that Ethernet frame has a destination address that's the broadcast address. In other words, it's a LAN broadcast frame. So for that frame to reach all the other devices, well, it's all the other devices in the LAN, and routers don't forward those ARP requests. So if A sends an ARP request, it gets to R1, and that's as far as it goes. All right, so if you apply that, and we will here in the next few moments, you'll see where the messages go. But first, let's look at the end result tables. That's one of the things I'd be listening for from you if you were actually answering me in a technical interview. But one of the key ideas with what ARP does is what it does not. It does not learn the MAC addresses of devices on other LANs in other subnets. That is, those devices on the other side of at least one router. So from host A's perspective, for instance, it won't learn the MAC addresses of those devices down below router R1. So if we just ask ourselves the question, this is a question I might follow up with if the person I'm interviewing didn't get there, was, what MACs can PCA learn with ARP? What could it possibly have in its ARP table? Well, A wouldn't learn its own MAC address and put that in its ARP table in regards to A knows its own MAC address already. It doesn't need to use ARP to learn its own MAC address. But it also wouldn't learn the MAC addresses that are on the other side of at least one router, like those that just fell away. All right. So the only one in this context that matters that A needs to learn is the MAC address of the router, the default router that it'd be using to send packets down to this server S2. All right. So that's something I would expect you to know. Now let's sit back for a minute and look at the IP addresses. We can calculate the subnet IDs, and you probably will have at some point along thinking through this problem. But here's the subnet ID and mask based on both of these IP addresses. Here's the subnet ID and mask of the middle subnet, and here's the subnet ID and mask of the bottom subnet. So the ARP tables of the devices in the subnet, basically they can have all the addresses, the IP addresses and matching MAC addresses of the other devices in the subnet. So we're just showing, say, for instance, the router and one host, but there might be, dozens of hosts out there. They would all be able to learn each other's MAC addresses with ARP. How many ever devices might exist out there? Now let's drill down on the specific ARP tables. Again, I'd be listening for this in the technical interview and say, well, what specific entries would there be? Well, host A is going to end up with an ARP table, and the router is going to end up with an ARP table with some ARP table entries. We'll focus on R1's ARP table entry to start. It'll list MAC1's MAC address with, host A's MAC address of MAC1 with host A's IP address that ends in 11.1, as you see here. All right. But R1's ARP table will also have a field for the interface, so it can keep track of out which interface it would use. What interface did it use to learn that MAC address? Then up at host A, its ARP table, it's going to list the router's IP address that ends in 11.254. It's generically speaking MAC2, and it will even list an interface. PCs can have multiple interfaces. PCs will assign an interface code. I show it here generically as Ethernet, but it might be something like ET0, ET1, ET2, something like that. So there'll be an ARP table entry on host A for the router's IP address and matching MAC address. Then, if we look further, there'll be ARP table entries on the two routers for the IP address and mask of the other router on the WAN link. For instance, here, we see R1's ARP table that lists the 1.2 address with MAC4 that's used by router R2. And the R2 ARP table will list MAC3 and R1's address that ends in 1.1. Notice in each case, R1 notes the interface ID used by R1. So it's R1's interface ID out which it learned that ARP table entry, and R2's interface ID on which it learned that ARP table entry. And then just to wrap up the ARP table look at that lower subnet, R2 and host S2. The R2 ARP table lists the server's IP address and MAC, and the server's ARP table lists the router's IP address and MAC. So if I'm interviewing you and your resume says you've got a CCNA, I don't expect you to master every little nook and cranny of how to use ARP in every situation, but I'd expect you to be able to go beyond just simply, hey, ARP is used to learn another device's MAC address, all right? So in this context, here's what I'd be listening for to see if I thought you maybe passed this part of the interview. I'd want you to think, hey, if A is going to send a packet down to server S2, then A is going to need to send packets encapsulated in an Ethernet frame to its default gateway. And that default gateway is going to be R1. To accomplish that, PCA is going to need to know R1's MAC address, and the mechanism for that is ARP. All right. Then when R1 receives a packet encapsulated in that Ethernet frame, the router is going to de-encapsulate the IP packet. Now, all of that gets back to routing, right? And I'm not talking about routing in this particular interview review, but that's the bigger, broader context, right? So I'd be listening out for those things as well here. But I would want you to be getting comfortable, to show that you've become somewhat comfortable with what should and should not be in that device's ARP table. Like that A does not need an ARP table entry for S2. All right. If you thought it did, then I would say that's a red flag that you really haven't grasped what ARP is about. But that A needs R1's upper IP address and MAC in an ARP table entry, I would definitely expect you to realize that that's needed. And then I'd say maybe bonus points if you realized, hey, there's going to be an interface ID referenced in each of those ARP table entries, particularly on the routers, which directs the router, hey, this entry is actually in the context of using that information for sending packets out that particular interface. So remember, host A is generating a packet to send to server S2 with all empty ARP tables, all right? So let's think about the ARP messages created by these devices in this case. So the ARP request, it lists a target IP address, that is the one it wants to discover the associated MAC address of. So we know the IP address, or the thing that creates the ARP request knows the IP address, wants to learn the MAC. And it's usually sent in a broadcast LAN frame, encapsulated in a broadcast LAN frame with the idea of, hey, everybody on this LAN, please consider this, with only the requested target sending a reply. So everybody here, target please reply. Now that ARP request also includes the sending devices, the sender's IP and MAC address. And those are some of the subtleties that I'd be listening for if I was interviewing someone. Now, the ARP reply that's sent back, it's sent by the original target, the target of that original request. It identifies that original target's IP and MAC address, but that one's usually sent as a unicast Ethernet frame sent back to the original sender, so only that device learns in the ARP reply. All right, so those are the generic rules. Let's see how they apply in this case. So no one has ARP table entries. A wants to send this packet. A says, I need an ARP table entry that says what MAC address to use to send a packet to my default gateway of 11.254 here. So let me send an ARP request onto the LAN with a target of 172.16.11.254 with a MAC field that designates, I don't know what your MAC address is. And over here in the Ethernet header, it's got an all Foxes MAC address, meaning this is a broadcast frame. So it gets flooded to everyone in the LAN, but it does not get forwarded by router R1 beyond router R1. So everybody in the LAN hears this, but only R1 is using that IP address that ends in 11.254. But first, it turns out that this ARP request, it has a target field, who it's looking for, but it also has a sender field with both the IP address and MAC address. It identifies host A's IP address and MAC. So R1, when it receives this ARP request, it learns A's IP address and MAC, puts it in its table, designates the interface that it received that ARP request in, gig 000, and it builds its MAC table based on the ARP request. Pretty cool, huh? So there it is. R1 is learned. Then R1 says, hey, that was an ARP request, listed me as target, so let me answer back with an ARP reply. It'll have a unicast MAC address in here of A's MAC address. Sends the ARP reply up there, and that ARP reply is going to list R1's IP address and MAC as requested, MAC2, and now host A can learn the appropriate MAC table entry as we've been talking about. All right, so that's the process. Notably, it was one ARP request and reply for both devices to learn the other's MAC address. All right, so it wasn't like both had to send an ARP request to learn. The process just works for both to learn with one ARP request and the appropriate ARP reply. Now you'll see that borne out with the messages in the middle and the bottom subnets. So if you look at the middle WAN link, those routers don't have appropriate MAC table or ARP table entries rather. So here at R1, it needs an entry before it can use a route that says send the packet to this next hop address. It's got to build an ARP table entry that lists the MAC address associated with next hop address 172.16.1.2. So R1 generates this ARP request. It's listing 172.16.1.2 as the target with the MAC address unknown. It also lists itself with its own IP address and MAC as the sender. So R2 adds the sender's IP address and MAC into R2's ARP table. Just to be efficient, R2 sends an ARP reply back listing R2's own IP address and MAC so that R1 can learn the appropriate MAC table entry. Now R1 can forward the packet down to R2. And then just to complete the puzzle, the lower subnet, I've just drawn it with only the lower subnet just to make space to write. R2 wants to forward the packet to S2. R2 doesn't know S2's MAC address. R2 needs to learn an ARP table entry for S2's IP address, so it sends an ARP request. Target is S2's IP address. S2 receives it, learns from it, learns R2's MAC and IP address, generates the ARP reply, supplying S2's IP address and MAC address, which R2 uses to fill up its ARP table. All right, so I don't know that I'd need you to tell me a systematic exactly what's happening with these things, but I'd be listening out for the basics of this. So what would my scorecard look like when I'm listening for this? Well, I put a lot of extras in this second wave in the interview review video here. So the things I would really want to hear, reasonable expectations, if you will. Which addresses are requested by which devices? A asks for R1's MAC address. R1 asks for R2's MAC address. R2 asks for server S2's MAC address, right? And that to ask all in the subnet, the ARP request is sent in a broadcast frame, and that the ARP reply is actually sent back in a unicast frame. I think those would be things I would hope you would have picked up while learning ARP. And maybe just counted as bonus points if you realize that one request-reply pair caused both devices to learn the appropriate ARP table entries, and the use of these terms target and sender, and the target and sender fields being in both the ARP request and reply in these ARP messages. That would be kind of a bonus thing to mention in the interview as well. So I'm going to give you one very short follow-up food for thought question. Let me ask you the same question. What ARP table entries are needed and what messages have to flow if server S2 immediately turned around and sent a packet back to host A? Did so immediately. What would happen? Well, I'll give that to you as a question to ponder. Feel free to comment and let me know what questions you have or thoughts you have on that, but I'll leave that to you. I'm not going to talk about it here in the interview review, so noodle that. Let me know what you think. Well, I hope you enjoyed this interview review. If you're ready for some new learning, click on the left and you'll be connected to the next instructional video, this one about connected and local routes. If you want more review, click on the right. It's another interview review, this one about routing between two hosts. I'll see you there in that next video.